Hey guys, Dr. Brown here with Kubo Math, and I have a little saying at the bottom of this screen that I want to read before we get going. And it says, "We do not rise to the occasion, rather we sink to our level of preparation." So how do we prepare? We study, and that's exactly what we're doing here tonight. Okay, this is one video of a several part series that I've been running in Calculus 2 about where did they get that formula. So we're deriving various formulations that are out there. Okay, so we have a table that says if you see this, then you need to let x equal one of those values, and then ultimately we can use something over here. So what do we see? We see that we have an integral of the square root of x squared minus a squared. So we have this guy right here, the square root of x squared minus a squared. So we're going to let x equal a secant theta. So x is going to equal a secant theta. Now dx would equal then, a is a constant, the derivative of secant theta is secant theta tangent theta. D theta. Oh, chain rule. Okay. Now then, let's plug some of that in here. All right. We've got square root of, we've got x, which is a secant theta, and that's squared. So we have x squared. Okay. I think I about pulled my cord out. All right, so we've got x squared minus a squared. Now dx is equal to a, so I'm going to put this in parentheses here, a secant theta tangent theta d theta. All right, now then, let's square what's inside here. So I've got a secant theta squared, so I've got a squared secant squared theta minus a squared. And I'm going to pull this a over here, kind of get it out of the way. Parentheses around that, secant, and all of that's times secant theta tangent theta d theta. All right, you can see I could factor out the a squared underneath. So this is very similar to what we did last week with a different one of those. So I factor a squared out and I end up with secant squared theta minus 1. Oh, so you can see if I distribute that, I'll get a squared secant squared theta minus a squared times this negative 1 gives me negative a squared. And that's times secant theta tangent theta d theta. All right, you know the rule. If I have a squared b squared and I take the square root of that, it's the same as saying square root of a squared times square root of b squared, which is what situation I have here. So I can take that a squared term, take the square root of it, pull it out here. So that would give me that a that I already have times the other a that I just pulled out times the square root of secant squared minus 1, which is what? Tangent squared. Okay. Hey, now it's looking good. Tangent squared theta, square root of that, times secant theta tangent theta d theta. So I've got a squared out here. A times a gives me the a squared. Now the square root of tangent squared is tangent. So now I have a squared times the integral of tangent. I'll just go ahead and write it out. That gave me this tangent, but I have another tangent out here. So I'm going to multiply those together to get tangent squared times secant theta d theta. So now that's the integral that I'm working with. So let's go up here. All right, so we have a squared times the integral of tangent squared. But what is tangent squared? I could write tangent squared as secant squared theta minus 1. So let me just do that. Secant squared theta minus 1. That was my tangent squared theta that I had here. And that's multiplied by secant theta d theta. Okay? Now let me go ahead and distribute that secant squared to the inside and then separate those two, well, I'll leave them together for the moment. The integral of secant theta times secant squared theta is secant cubed theta. Actually, I'm going to go ahead and separate them. D theta minus, and I'm going to carry this a square along instead of putting a big parentheses around it. If you're like me, I lose that. That's one of my kryptonites. So sometimes I'll carry things along, which may clutter it some. You may not have to do that, but I do because I'll lose it. So I know what my kryptonite is, and this is how I work around it. Okay, so now I've got secant theta d theta times the negative 1, and again, times this a squared. So a squared times the integral of secant theta d theta. Okay, so you can see what I've done here. Now, in one of our previous videos, we've already calculated what secant cubed theta is. We've also calculated what secant theta is, the integral of those. So I think it was in the video completing the square. So look that one up in the calculus, in the Kubo math, and you'll find those where we derive both of those, because that's one of those that you're going to repeatedly need to remember in your head. Okay, so what is the integral of secant cubed? I'm going to keep my a squared here. It is 1/2 times secant theta tangent theta plus 1/2 natural log of secant theta plus tangent theta. That would be the absolute value of those. Okay, now that a squared is times both of those. I better throw that in here. All right, that gives us that integral minus, I need to wipe out a spot here, it looks like. Minus this a squared times that integral, and this one is the natural log of secant theta plus tangent theta. Okay, so this is the integral of secant. Of course, this negative came from up here. And then we have all of this other is the integral of secant cubed. So what do we end up with here? You'll notice these terms, a squared over 2, natural log of secant theta plus tangent theta, is the same as this, except this is 1/2 of this and this is a whole. So if I subtract a whole one of these from half, a positive half, I end up with a negative 1/2 of this. So where do we end up with here? We have a squared times, well, let me pull that 1/2 just to the outside and kind of clean that up a little bit. 1/2 times a squared secant theta tangent theta minus, so we're subtracting a whole from a half, so it gives me a half, or a negative half, so a squared over 2 times absolute value of secant theta plus tangent theta. Whoa, okay, what do we do with that? Well, we've got to get it back to the x world for one thing. We've gone from the x world into the theta world, and we've got to get back to the x. Well, we know we had x equals a secant theta. So we have a situation where secant is the opposite of cosine. So it would be if x equals a secant theta, if I divide both sides by a, so x over a equals secant theta. So x over a equals secant theta. Of course, this side then would be x squared minus a squared and the square root of that. So that gives me the triangle, obviously with that being theta. All right, so we could say, let's go ahead, 1/2 a squared, secant theta, secant's x over a, tangent theta is opposite over adjacent, so that would be the square root of x squared minus a squared over a minus a squared over 2 times the, oh, that should be a natural log here, sorry. Hopefully you were in the screen earlier going, oh, he missed it, he left the natural log out. There's my natural log, I should have put it here. All right, so the a squared over 2, natural log of secant, which was x over a, plus tangent, which is the square root of x squared minus a squared over a. Okay, so I can clean that up a little bit. I've got an a squared here. A times a is a squared. That one will cancel. And now I am going to pull the 1/2 out. So I end up, these cancel. So I end up with x times the square root of x squared minus a squared minus, and I pulled the 1/2 out, it's over here now, a squared times the natural log of x over a plus square root of x squared minus a squared over a, close the absolute value sign, all of that plus c. And that, my friend, would be how we could integrate that formulation. Now this is something, this formula, when you see this, you don't have to do the entire integral again, you just write this down. Now I don't remember all of these, maybe when I was younger I did. Now I just know where to go get them. So I have in my phone a Trig page and tools. I have two folders, and so I go and, okay, is this one of my tools that I have? Of course, you do enough of them, you know, okay, I know where it is. I go get it. So again, key here was knowing secant cubed and secant theta. So go back and look at those, and just message me if we need to go through that one again, because we certainly can. So, all right, that's all for now. And why are we doing this? Together we're trying to build a better tomorrow and do that through math, okay? And don't, you know, we want to, if we don't rise to the occasion, rather we sink to our level of preparation. So prepare by studying. Work that math, okay? All right, that's all for now, and we'll talk to you next time. Thanks.